Okay, Assalamualaikum. This is IP Chemistry, topic acid and base. Okay, on this video, I'm going to explain about the acid dissociation constant. Alright, so the acid dissociation constant have a formula equal to Ka. Okay, so in aqueous solution, all weak acid act as bonds to the weak acid and donate a proton, which is hydrogen ion, to another substance. So here I list the general equation for the dissociation of acid in water. Let's say acid is equal to Ha. So in water, acid will donate proton, so water will form hydronium ion and it produce A minus, okay, which is this is the weak base, okay, conjugate weak base of the acid. Alright, so from this general equation of dissociation of acid, we can come out the equilibrium expression. Okay, so the expression is the concentration of hydronium ion times concentration of A minus, or the weak conjugate base, divided by the concentration of acid Ha times concentration of water. Okay, so this is equilibrium constant. Okay, but at a temperature 298 Kelvin, okay, at this temperature, okay, the concentration of water is constant. The concentration of water is constant, or I can say that the concentration of water is very low and dilute. That's why we can cancel out the concentration of H2O. So the formula is equal to concentration of hydronium ion times concentration of A minus divided by concentration of Ha, which is acid. Okay, so this is the formula of a Ka come from. Okay, so in a dilute aqueous solution, concentration of water can be considered as a constant. Okay, because the degree of dissociation of water is very small. Okay, we know that the water can dissociate into hydrogen ion and hydroxide ion, but the degree of dissociation is very low. That's why at the room temperature 25 degrees Celsius or 298 Kelvin, the concentration of water can be ignored. Okay, alright class, so this is the formula for Ka. So this is formula come from the dissociation of acid in water. Okay, this is another example. Okay, I give example for the ethanoic acid. Ethanoic acid. So when it dissolves in water, it produces ethanoic ion, A minus before, and hydronium ion. Okay, this is plus. Okay, hydronium ion. So the Ka is concentration of ethanoic ion times concentration of hydronium ion, which is come from the product, and divided by the concentration of ethanoic acid from the reactant. Okay, this is the formula of Ka. This is how we come out the Ka formula from the dissociation equation of acid. Okay, so for the weak acid, the value of Ka usually quite small and can be conveniently represented in a logarithm from similar to pH. Okay, so from Ka we can find the pKa similar to the pH. We can calculate pH if we know the value of concentration hydrogen ion. So we can calculate the pKa if we know the value of Ka. So how to calculate the pKa? pKa is equal to negative log Ka. Okay, alright. Okay, so what is Ka actually? Okay, so the strength of weak acid is determined by its value of Ka. The strong the acid, the higher the concentration hydrogen ion or hydronium ion, the lower the pH value, the larger the value of Ka, and the smaller the value of pKa. Okay, that's why we have to calculate the Ka or and pKa, because the value of Ka and pKa can represent the strength of the acid. Okay, the bigger the value of Ka, the stronger the acid, or the smaller the value of pKa, the stronger the acid. Okay, so this one, the dissociation constant Ka. Okay, here I list down a few type of acid. Okay, so you can see the pattern from the hydrofluoric acid to the hydrocyanic acid. The pKa increase. The pKa increase. Okay, we know that when the pKa increase, the strength of acid become weaker. Okay. And the pKa is opposite to the Ka. Okay, the greater the number of Ka, the smaller the number of Ka, the weaker the acid. Okay, you can see that. Okay, the smaller the number of Ka, when going down the table, okay, the weaker the acid. Okay, alright. Okay, example, calculate the Ka value of methanoic acid. Okay, at 25 degrees Celsius of 0.100 mole per decimeter cube, solution dissociates to give hydrogen ion concentration of 4.13 times 10 negative 3 mole per decimeter cube. Okay, so how to calculate the Ka here? Right, so we have to write the chemical equations for what type of acid? Okay, methanoic acid. Okay, so methanoic acid, the formula is HCOOH. This is aqueous, and it dissociates into HCOOO minus aqueous to H plus aqueous. Okay, then okay, calculate the Ka value. Calculate the Ka value. Hydrogen ion. Okay. Dissociate. Okay. So this one, solution is okay. So for the initial concentration 0.100. Okay, and then it change. Okay, 0.100 minus x. This one plus x. And the final concentration is 0.100 x. Okay, to give the hydrogen ion concentration. Okay. Right, so hydrogen ion. Okay, here the question already give the concentration of hydrogen ion, so equal to 4.13 times 10 negative 3. Okay. Right, so this is value of x, meaning that for ethanoic ion also have the same concentration because it has same ratio. Okay, so how to calculate the Ka? So Ka equal to HCOO, okay, times H plus divided by concentration HCOOH equal to Kx times X HCOO, okay, 0.100. Okay, just insert the value 4.13 times 10 negative 3, 4.13 times 10 negative 3 divided by 0.100. Okay, then just use your calculator. Okay, alright, so 4.13 negative 3, 4.13 negative 3, okay, divided by 0.1. Okay, here is the Ka. Okay, Ka is equal to 1.7 times 10 negative 4. Okay, so this is Ka. Okay, Okay, the next example, calculate the Ka value of HCN. Okay, at 25 degrees Celsius, if 0.500 mole per decimeter cube solution dissociates to the given hydrogen ion concentration of 1.41 times 10 negative 5 mole per decimeter cube. Okay, the same process. Okay, write the chemical equation for HCN aqueous and produce hydrogen ion aqueous plus Cn aqueous. Okay, this is weak acid, so for the initial concentration 0.500, and then it change 0.500 minus X plus X plus X, so the final concentration 0.500. Okay, why the final concentration of HCN is 0.500? Because the value of X is very small. Okay, so X here is okay, 1.41 times 10 negative 5. 1.41 times 10 negative 5. Okay, right. Even since that the question already give the value of X, so we have to subtract the X. Okay, but the question not give the value of X, we no need to minus with X. Okay, 0.50 subtract with X will same with the initial concentration, but if the value of X is given, you have to subtract. So here is what 1.41 times 10 negative 5. So the answer is okay, 0.5 minus 1.41 e negative 5. Here is 0.4999. Okay, actually sebenarnya you still get the 0.5. Okay, that's why we no need to subtract with X. Okay, alright. So what is your Ka? Your Ka is equal to H plus times concentration of Cn and divide by concentration of the HCN. Okay, so 1.41 times 10 negative 5. Okay, wait. Okay, 1.41 times 10 negative 5 divided by 0.500. Okay, equal to 55 divide by 0.5. So the answer is 3.97 6 times 10 negative power negative 10. Okay, so this is your Ka. Okay, class. So this is how to solve the question, how to calculate the value of Ka. Okay, that's all for me. Thank you.